let's take a look at number 1. So here we're trying to approximate the area under the curve from 1 to 2 of 1 over x. Now, we don't really need a graph to do this. We can do it without, but just to help visualize what's going on here, let's take a look at the graph y equals 1 over x. So our curve is going to look like this. So we're going from 1 to 2. All right, so let me fix that. So we're going from 1 to 2. We want to find this area under the curve. And we're approximating that using 4 subintervals. So we're going to break this into 4 parts. So remember, we can figure out delta x by taking b minus a over n, the number of subintervals. So we get 2 minus 1 over 4. So delta x is going to be 1/4. So if we break this into 4 parts, it should make sense. Right here is going to be 1/4, 1/4, 1/4, and so on. So right here, that's going to be 5/4, 6/4, or 3/2, and 7/4. We're going to find the area of these 4 trapezoids and add them up. That's how we're approximating this. Now you could go ahead and just use that formula for a trapezoid, 1/2 base 1 plus base 2 times height, and figure out each one and add them up. And you're going to get the right answer. It's just going to take you longer than it needs to. If we were to do that, this would be our base, this would be another base. So base 1 and base 2. Our height of the actual trapezoid would be 1/4. This base plus this base, height is 1/4, and so we'd have 1/2 times this plus this times 1/4, and so on. So we can find each one. But using our formula up there that we just talked about in the intro, we've got 1/2 times delta x times f of x sub 0 plus 2 times f of x sub 1 plus 2 times f of x sub 2. Right, so this would be like our x sub 1. Use a different color. X sub 0, that's our x sub 1, x sub 2, x sub 3, and x sub 4. So we've still got a little ways to go here in our formula. Plus 2 times f of x sub 3 plus just f of x sub 4. All right, so that's our formula. Basically all we're doing is we're taking that delta x that we found times 1/2. F of x sub 1, that's the, f of x sub 0, that's the y value we get right here. So if we put 1 into this function, right, into this function here, if we put 1 in, 1 over 1 is just 1. So we're doing f of 1, which is just, I'll write this here, plus 2 times f of 5/4 plus 2 times f of 3/2 plus 2 times f of 7/4 plus f of 2. Now you may not need to write all this stuff out from each problem, but I'm just trying to kind of show you, for the first one at least, where everything's coming from. So you get 1/8 out in front, f of 1, if we put 1 in there, we just get 1, plus 2 times f of 5/4. If we put 5/4 in here, 1 over 5/4, that just means the reciprocal of 5/4, right? 1 over x is the reciprocal of x. So that's going to be 4/5 plus 2 times f of 3/2. We put 3/2 in there, we're just getting the reciprocal, which is 2/3, plus 2 times 4/7 plus 1/2. So we can add all of these up here. And if you add all those up, you get approximately 0.697. And to kind of show how nice of a approximation this is, let's actually find out what the definite integral from 1 to 2 of the function 1 over x is. So remember, we could do this using our calculator. If we want to do this on our calculator, pull that up. We can do math 9, and our function is 1 over x, comma x, comma 1, comma 2. And we get about 0.693. Only 4 thousandths away in our approximation, so that's a pretty good approximation using that trapezoidal rule.